Hello, welcome students. Good day all of you. Dear students, in 11th chemistry chapter, adsorption and colloids, we have studied few topics till now in different videos. Now this is our next video. Myself is Ravindra Budwan sir from Sri Tilok Jain Higher Secondary Vidyalaya Pathardi, and this is my next video which will be very useful to you. Dear students, in this topic we are going to study catalysis. Till now we studied the adsorption. It was the first concept in this chapter, but now this is the second concept, second topic in this chapter, and that is catalysis. So catalysis, this is the phenomenon which is exhibited by the particular substance known as catalyst. Now this catalysis phenomenon, it is very important in different industries for preparation of various chemical substances, chemical compounds. It is also important in laboratory, and mostly it is very useful in the bodies of animals. So whatever physiological processes take place in the animal bodies, they are catalyzed by certain catalysts known as enzymes. So without catalyst, without enzyme, these processes cannot take place. That means for the regulation of our physiological processes in our body, the catalyst, that is enzyme, is of utmost importance. So what is the work of catalyst in the chemical reaction? The work of catalyst is to increase the rate of reaction, to enhance the rate of reaction. Catalyst is the substance which does not take directly part into the reaction, but it carries out the reaction, it increases the rate of reaction, it reduces the reaction conditions which are required for it. For example, without catalyst, the reaction requires high temperature or high pressure, but with catalyst or by using the catalyst, the temperature of the reaction can be reduced, the energy of activation can be reduced, pressure can be reduced. That means at normal condition or at soft condition, we can carry the reaction, we can obtain the desired product in the reaction with the help of catalyst. So catalysis is very important phenomenon in case of chemistry and the related fields. The definition of catalyst is a substance which, when added to a reacting system, increases rate of reaction without itself undergoing any chemical change, permanent chemical change. So that substance which is added to the reacting system, that is to a chemical reaction, into a chemical reaction, that is helpful for increasing the rate of reaction, enhancing the rate of reaction, but it does not undergo any permanent chemical change into it, that is without undergoing any permanent chemical change. So there is no chemical change in the catalyst. We know that the chemical change occurs in the reactants as well as the reagent to form the product, but whatever catalyst is used, it does not undergo any permanent chemical change. It only works for increasing the rate of reaction, or it helps to increase the rate of reaction without undergoing any permanent chemical change. Catalysis, this phenomenon, it is of two types depending upon the state of the matter, that is physical state of the reacting system, that is reactants, and the catalyst. So there are two types of catalysis based upon the physical state of reactants and catalyst. So first is homogeneous catalysis. So first type is homogeneous catalysis. Now this word homo means same. Word homo means same or equal or identical. Homogeneous, genius, it is refer to the phase. So this homogeneous word, it means same phase. Now what same phase? Same phase of reactants and catalyst. So the reaction in which reactants and catalyst are present in the same phase. Same phase means same physical state. For example, all reactants and catalyst is present in solid state. All reactants and catalyst are present in liquid phase. All reactants and catalyst are present in gaseous state. So this will be the situation in the homogeneous catalysis. Examples are given: I minus aqueous, that is iodine ion, I minus ion dissolved into water, so aqueous, that is I minus iodine minus ion produced in the solution. It is used in decomposition of aqueous H2O2. So in the decomposition process of aqueous H2O2, decomposition of H2O2 produces hydrogen and oxygen gases, but aqueous, that means solution of hydrogen peroxide. H2O2 is hydrogen peroxide. So in decomposition of hydrogen peroxide, we use iodine minus this ion in aqueous phase. So both are in aqueous phase, I minus present in the solution and aqueous H2O2 hydrogen peroxide, both are in aqueous phase, that means in the liquid phase, liquid, that is solution prepared in the water. Second example is nitric oxide, NO. Nitric oxide catalyzes the reaction of oxidation of sulfur dioxide to sulfur trioxide, oxidation of SO2 to SO3. So sulfur dioxide is oxidized to sulfur trioxide in the gaseous state in presence of the catalyst nitric oxide, that is in the gaseous state. Here you can see this is the reaction for oxidation of sulfur dioxide to sulfur trioxide. So sulfur dioxide plus O2, both are in gaseous state. Sulfur dioxide gas SO2 plus oxygen gas O2 in presence of the gaseous catalyst nitric oxide, we get the product sulfur trioxide in the gaseous state. This is an example of homogeneous catalysis. Then another example, H plus ion from H2SO4, that is sulfuric acid, in hydrolysis of sucrose solution. Now we know sucrose is hydrolyzed to get glucose and fructose, one molecule of glucose and one molecule of fructose. Molecular formula of sucrose is C12H22O11. When it is hydrolyzed, that means one water molecule is added in presence of catalyst sulfuric acid, we get one molecule of glucose C6H12O6 and one molecule of fructose C6H12O6 in the aqueous state. So here H plus ion from H2SO4, that is in aqueous state, it is used as a catalyst for hydrolysis of sucrose. You can see here the reaction. This is sucrose C12H22O11 in aqueous phase, that is water solution, then plus H2O in liquid and aqueous phase is also liquid phase. So water in liquid state in presence of H2SO4. So H plus from this H2SO4 act as the catalyst. Here we get C6H12O6, that is glucose molecule, and C6H12O6 another molecule, that is fructose molecule in aqueous state. So this is another example of the homogeneous catalysis. Then enzyme catalysis is also example of homogeneous catalysis. Enzyme catalysis means different enzymes in the physiological processes, they are in the same phase with the reactants and they act as the catalyst. It is called as enzyme catalysis. Now we shall go to the second type of catalysis, that is heterogeneous catalysis. Now this word hetero means different. Hetero means different, genius phase. So heterogeneous, different phases. Heterogeneous catalysis involve the reactants and catalyst in different phases, that is in more than one phases. That means either of them will be in solid, liquid or gaseous phase and another one will be in the different phase out of these three. So it is called as heterogeneous catalysis. Reactants and catalysts are in the different phases. So in the heterogeneous catalysis, the reactants and catalysts are in different phases. Out of the reactants, if there are, let's say, 2 reactants, then one reactant may be with the same phase as the catalyst, but another reactant will be in the different phase. That means any one of the reactant is in different phase than the catalyst, then it is the heterogeneous catalysis. So generally catalyst solid and reactants are gases or liquids. So generally what is observed in heterogeneous catalysis, that the catalyst is in solid state and the reactants are in gaseous or liquid phases, that is reactants may be gases or liquids. Catalyst does not dissolve in the reacting system. Now as it is in the solid state and the reactants are in liquid or gaseous state, the catalyst does not dissolve in reacting system. If it gets dissolved into the reacting system, then it will be homogeneous mixture, then it will be homogeneous catalysis. But catalyst here being in solid state, it does not dissolve into the reacting system, and therefore reactants and the catalyst, they remain in the different phases. Reaction occurs on surface of solid catalyst. On the surface of solid catalyst. Now what happens? Let's say this is the surface of the catalyst and the reactants are in the gaseous or liquid state. Then reactants molecules, gaseous molecules or liquid molecules, particles, they get adsorbed on the surface of the catalyst, solid catalyst. This is, let's say, one reactant. Another reactant also, the molecules get adsorbed on the surface of the solid catalyst, and then the reactants, they come into contact. Reactant 1, reactant 2, whatever there are, they come into contact with each other. They come close to each other, and therefore reaction takes place. So this is the phenomenon or principle behind this solid catalyst. So reaction occurs on the surface of solid catalyst. Examples are given here. N2 and H2, dinitrogen and dihydrogen gases, they combine to form ammonia gas. It is known as Haber's process. This process is called as Haber's process of preparation of ammonia gas from nitrogen and hydrogen gas in presence of finely divided iron. So it will be in solid state. Finely divided, that means powdered iron element or metal, along with K2O, potassium oxide, and Al2O3, alumina or aluminum oxide. Then hydrogenation of vegetable oils. Hydrogenation means addition of dihydrogen of vegetable oils to solid fat. Vegetable oil is present in liquid state. It is converted into solid state, solid fat, by hydrogenation. So hydrogenation of vegetable oils to solid fat, it is catalyzed by finely divided metals like nickel, palladium or platinum. We know the catalytic hydrogenation process, catalytic hydrogenation of alkynes and alkenes to form alkanes. So here unsaturated vegetable oils are converted to saturated fats by catalytic hydrogenation, and here the catalyst used is in solid state, that is nickel, palladium or platinum. These metals are used as the catalyst, whereas the reactants are in liquid state, that is oil, it is in liquid state. Then another example is automobile catalytic converter. Automobile catalytic converter, that is present in the automobile field, automobiles, vehicles, which transforms air pollutants like carbon monoxide or nitric oxide into carbon dioxide, H2O, N2, then dinitrogen and dioxygen gases. So automobile catalytic converter, it is in solid state. It transforms or converts the air pollutants, that is gases polluting air, carbon monoxide or nitric oxide. They are converted into another gases, carbon dioxide, water molecules or water vapors, then dinitrogen gas, dioxygen gas, so and so on. So these are certain examples of heterogeneous catalysis. So students, these are very two important types of catalysis, that is homogeneous catalysis and heterogeneous catalysis. In homogeneous catalysis, reactants and catalysts are present in the same phase. In heterogeneous catalysis, reactants and catalysts are present in the different phases. Now we shall go to the next topic, inhibitors. It is another smaller topic in this chapter, inhibitors. Inhibitors are opposite to the catalysts. That means we studied just now that catalysts increase the rate of reaction, whereas inhibitors decrease the rate of reaction. They retard the reaction. They do not enhance the reaction, they retard the reaction, they decrease the rate of reaction. So the substances which decrease rate of reaction, rate of chemical reaction, are known as inhibitors. The substances which decrease the rate of reaction, chemical reaction, they are known as inhibitors. Inhibit means to stop or to decrease. So the substances which decrease the rate of reaction are known as inhibitors. Examples are given here. 2% ethanol, CH3 CH2OH, we know ethanol or ethyl alcohol. 2%, that means very dilute. 2% ethanol, it is added to chloroform, which retards the reaction of formation of carbonyl chloride, that is COCl2, which is a poisonous substance by air oxidation of chloroform. That means when chloroform it is kept open in air, chloroform kept open in air, it undergoes oxidation. It is oxidized by air oxygen present in air to form the carbonyl chloride. This is the compound COCl2, carbonyl chloride, plus water molecules and chlorine gas is given out, it is evolved. But we don't want this oxidation of chloroform. So for that, to avoid the oxidation of chloroform, a little amount of 2% ethanol is added to the chloroform, which retards the oxidation reaction or which inhibits the oxidation reaction. Second example is dilute acid or glycerol. Any dilute acid, sulfuric acid or hydrochloric acid or glycerol, it is used as inhibitor in decomposition of hydrogen peroxide H2O2. So decomposition, that means breaking of this molecule into two smaller molecules. So here is the reaction, hydrogen peroxide H2O2, two molecules in liquid state. It is decomposed, it gives twice of H2O, two water molecules in liquid state, plus O2 oxygen molecule, that is dioxygen O2 in the gaseous state. So this dilute acid or glycerol, when added to hydrogen peroxide, it reduces the rate of this reaction, retards the rate of this reaction. So these inhibitors are used for those purposes, for the purpose of retarding the reaction which is not desired, which we don't want, the products here. For such processes, such convergence, to decrease the rate of such convergence, the inhibitors are used in the industry or in the laboratory. So these are the two concepts in this chapter, catalysis and inhibitors. In the next further upcoming videos, we will be seeing some more important topics in this chapter. So don't forget to see my further videos. Thank you very much.